যাচ্ছে, লাইট দেখা যাচ্ছে সুন্দর মতো করে?
বোর্ডটা ভালো দেখা, এইটা ভালো দেখা যাচ্ছে না, সাদা হয়ে গেছে এটা। এবার হচ্ছে
দেখে তো অন্ধকার।
হ্যাঁ
এবার আমি লাইট দিচ্ছি, ডাক্তার এবার নরম লাইট দিয়ে দিচ্ছি। ওকে, আসসালামু আলাইকুম। তো আমরা মাইক্রোপ্রসেসর ইন্টারফেসে আজকে নেক্সট ক্লাস করতে যাচ্ছি। তো বেসিক্যালি খেয়াল করে দেখেন, আমরা কি এর আগে এগুলো মানে যারা করেছে মিলে পরে আমরা কি করছি বলুন তো?
হচ্ছে যে মিডিয়াম ম্যাক্সিমাম সব ওই যে মাল্টিপ্লেক্সিং যা 7 সেগমেন্ট ডিসপ্লে ওইটা করছে 2 ডিজিট সিঙ্গেল ডিজিট। আর তারপরে এই যে সেন্সর হচ্ছে এই যে LM35 এগুলো করছে।
তার মানে সেন্সর শুরু করছি, তারপর
7 সেগমেন্ট
7 সেকেন্ড, আর
এই দুটো টপিক
আর কিছু পড়ানো হয় না?
এই দুটো রয়েছে। সেটা কয়েকটা পার্ট ছিল ওই যে
হ্যাঁ হ্যাঁ, সেন্সর আমরা শেষ করে একটা সব বলি ক্যালিব্রেশন আছে। 7 সেকেন্ড তো পুরোটা করছিলাম তাই না?
7 সেগমেন্ট স্যার যে সিঙ্গেল ডিজিট
সিঙ্গেল ডিসপ্লে,
2
ডাবল
ডিজিট
ডিসপ্লে, 2 ডিসপ্লে,
এই তিনটা
যোগ কেমন হচ্ছে, কোর, অনেক কিছু আছে। সো 7 সেকেন্ড থেকে 1 or 2 সেট আসবে, আর সেন্সরস থেকে আসবে 2 থেকে 3 সেটস। টোটাল কি 4 সেট না? কোশ্চেন করতে পারছে
4 মানে 5 সেট হবে 4 সেট
5 সেট হবে, 4টা অ্যানসার করতে হবে। হ্যাঁ, 3 আর 2 ঠিকই তো আছে, 3 আর 2 হয়ে গেল 5। তো টেনশন করার কিছু নাই, ইনশাআল্লাহ সোজা হবে কোশ্চেন, বাট জানতে হবে, মুখস্থ কিছু নাই। So first of all, before starting the class, we will have to recall our LM35 sensors. That's the basic of the these chapters. So I've talked about this 180. There's the digital touch sensor and how the sensor runs, the working prototype, the circuit diagram, and the operations, how it operates actually. See, there is a resolution of something that has DS180 sensors, and DS is Dallas company sensors. Okay, sensor, whatever. So 12 bit equal to 1 bit for sign, and 7 bit for integer part, and 4 bit for fractional part. Okay. So basically, if you want to explain the whole bit in a nutshell, then you will find something new. Like what? Whenever we are sending a data, like a RAM or something, there will be sections over there that every box and every section is considered to a bit. Okay? And that bit will start from bit 0 to bit 15. So basically, how many bits are over there? 16 bits.
16 bit.
So that's the integrated part that is written over there. How? See? It will be 9 bit, 12 bit data, 11 bit data, 10 bit data, 9 bit data. Every time, every single time, 1 bit is for sign. When it comes to 12 bit, 1 bit is for sign. I mean, it indicates whether it will be the positive or the negative. Okay? Fine. 7 bit. So, at the time of 12 bit, so 1 is sign. Okay? S. How many bits remaining over there? 11. So, among the 11, 7 bits for the integer part, like B10 to B4. Okay? So, let me clear this. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, that's a 12 bit. Okay? So, it will be B0 and it will be B11. Right? So, the first bit or the last bit, whenever we start from the, at the time of start, we will start from the right side and we will end up to the left side. Okay? So this bit is a sign bit, and what are they calling to the others? 7 bit is for the integer part, B10 to B4. So if it's B10, B1, B2, B3, B4, this region is the symbol of integer part. Integer means integer number. Okay, you will find some integer number. B4 to be 10. So B4 to be 10, 4, 5, 6, 7, 8, 9, 10 is a 7 digit. These 7 digits, look at that. These 7 digits, what? That indicates the integer part. So if I ask you a question in the exam, do you think that it need to be memorized or it need to be keep in your mind, something like that, you will copy and paste over there? No. If I ask you the resolution is what? If you find something to the power in a range, then we will find its resolution. Okay? So it could be 2 to the power 4, 2 to the power 5, to a square. So every time this cube means 8, this 4 means 16. So what will be our resolution? 4. So this means the power 4 indicates the bit 16. So it depends on the base. It depends on the power, not the base. Okay? Because the power is every time the power is getting changed, and depending on the changes or depending on the particular value, you will get the ultimate bit, and that's called the ultimate resolution. And that resolution is what? For the DS180B20 sensor. And this DSB120 sensor is basically a digital temperature sensor, if I'm not wrong. Yes, that's a digital temperature sensor. Okay, so do you get my point? Now come to the another
analog আর ডিজিটাল যে স্যার যে সেন্সরটা এর মধ্যে অনলি পার্থক্য স্যার হচ্ছে ডিজিটালে আমরা একটা রেজিস্ট্যান্স থাকবে।
Yes.
দুইটা
Yes. We have discussed this in the last class. So there will be resistance over there, and you don't need to identify the other stuffs. But in the analog sections, the basic difference is all of the resistance. Okay, and the circuit. There will be single changes, maybe a wire with a particular resistance and the ground. So that changes indicate that yes, this is the signal and this is the sign, or this is the schematic diagram of analog sensor, and this will be the schematic diagram of the digital sensor. So we have discussed this in the last class. Now we are focusing on what? We are focusing on 12 bit and 4 bit for fractional part. Okay, so 4 bit is for fractional part. Which part? Fractional. So the number could be 23.3. So this part indicates B3 to BO. Okay, same goes for here. 1 bit for sine, 7 for integer, 3 for fractional. 1 bit for sine, 7 for integer, 2 bit for fractional. 1 bit for sine, 7 bit for integer, and 1 bit for fractional. So every time that bit, particular bit, is not fixed. I mean, they are not fixed, but the constant is the sine bit and the integer part. Because every time the fraction is getting changed, and these changes are particularly based on the sections on this bit. Okay. So you may ask where it comes from, or how would it start this bit counting? So every time bit 4 is a key factor or the key bit or the key box or the key room where it starts counting 0. So this relation comes from here. Okay, 0, 1, 2, 3, 4, 5, 6. So ultimately we are working on to the power 6. The rest of the bit indicates the sign language. The sign part actually. Fine. We have to cover up the other stuffs, and that cover with S. So S means sign. And every time the fraction is getting changed, just in the proportion of this. Do you get my point? Okay. So that's how this resolution works. So if I ask you about the resolution and the bit, you have to write on this topic. Okay. So that's the another bit level, and here's some data like how it works, temperature conversion time. So it's a data that has been measured in a room or a particular resolutions, the maximum with the measured value, and how this millisecond work actually with the particular resolution. And the procedure to measure temperature conversion time at various times, there will be some figure, it's figure per 1. I think this is the figure 1, and that's how the setup can be made, and you have to take the value. Okay, Now, set resolution to 9 bit and then 10 bit, then 11 and 12 as per figure 1. Start DS18B20 conversion. So start millis based on the timer to store conversion time. Start millis. What is millis function?
10 to the power minus 3.
Yes, millis functions indicates the milliseconds. Okay, that has been set up into the Arduino. And you don't need to write like this: procedure 1, step 2. Okay. So if you look at table 2, then you get thermometer resolution configuration. That's not so much important. That's not going to be bothered to you, and I'm not going to be bothered with this codes and the lines. But the fact is, you have to know this algorithm, and you have to know and familiar with this one. Okay, that's really important. And the other part's not very important because the syllabus is getting short and time is very, very short. Then we have to wrap up things in a short way. Fine. How it works actually and how this system organized. Okay. So if I look at this is the Arduino Uno. So you have an Arduino in your hand. What's going inside in it and what's the purpose of this and how this works? That's a very root level schematic diagram over there. So there will be T expert and R expert. So basically it may be pin 0 or pin 1 at the right side of the Arduino. Okay, it's set over there. There is storage array over there. So for the storage array, that's you may call that the buffer array. And DDRB2. So DDRB2 it indicates most probably the digital pin something. And that particular level is connected with over there.
So DDR2 is like a RAM, no?
Yeah. DDRB2 is the RAM. DDRB2. Yes, DDRB2 is a particular RAM. This RAM, DDRB2 is the RAM. DDRB2. So basically, no, it's not a RAM. It's basically you can it's data register port. It's a register. It's not a RAM. You can call it in general it's a RAM, but it's a register. Okay. So
memory.
Yes, you can work it in memory, and this memory will be run like 0xFF. That's a hexagonal digit. Okay. And that initialized with the 00. Okay, so that is connected to the port pin, and that port pin is completely I got to work as an input. Okay, fine. Yeah. So basically, this RAM. I have talked about this particular bit system. So this bit system, see, this particular bit system, the resolution has been connected with this. Okay, so you have a resolution. Particular resolution, that how it forms. This resolution has been internally connected with this Arduino TXP. Okay, and that Arduino is connected with what? With this particular resistance and 5-volt source, and this could be the digital pin 7 or something like that. Okay, so DS1 in P20. This DS1 in P20 is a particular what? Sensor. Okay. So how it works actually, this total conversion, the temperature conversion is over there, and it's a memory sketchpad. Memory sketchpad means you can, if you look at a memory, you will see you will notice some solid something. Okay, but inside of the memory, what's going on over there, what's deep inside, and how it works, that will be defined over there. Okay, see. So whenever it comes to a memory side, it has what? Other ROM code of 64-bit unit. So this module, this particular module has been connected with the temperature sensor. Whenever it connects with the temperature sensor, there will be some value integration over there. this value integration will work with this scratch pad memory. Could you please tell me about this scratch pad memory? It's 8-bit or 10-bit or 12-bit or something. What? It's an 8-bit memory because this 0 memory is from 0 to 7. Okay, so 0 to 7 means it's a lower 8-bit, upper 4-bit, high, low, bit 6 and 5. So basically, this bit has been operated with the temperature sensor when it comes to a lower 8-bit and temperature signal to the upper 4-bit. So you have different type of signals, different type of range where you can execute your particular values with what? With the fraction number over there, with the integer number over there, and the sign bit over there. So that's the same way there is a bit and a memory over there. That particular memory has been certified with particular sections, and that sections will integrate and will generate different type of value while connecting with the particular DSP digital sensor. Okay, so how it works? Temperature sensor will work the lower 8-bit. So what do you think of the lower 8-bit? What do you mean by lower 8-bit? Is it something to the right side to left side, or this left side to right side?
Lower 8-bit.
Lower 8-bit. So obviously it will start from 2 to the power 0 or something, or 2 to the power -2 or something. That will be considered to be concept to the front side, to the left, to the right, and gradually increase its value. So lower 8-bit means obviously center or something to the right side, to the right portion. Upper 4-bit, obviously this 4-bit or something like that, excluding the sign bit. Okay. So temporal signal will generate from upper, temporal signal will generate from lower, and temperature alarms at the high and alarms at the low. Why this set is high and low? Because initially what? There will be the memory, this register will start from 0xFF with the value of 0. Okay? 0x00, it means 0. It indicates the hexagonal number. This register is occupied with the hexagonal numbers. Okay? So now, low and high, it means you have to set the alarm just to ensure that yes, now it's low, and at the time of at particular time being, then we consider the high. Configuration bit 5 and 6. What do you mean by configuration bit? Please, what do you mean by configuration bit? So what I say is 64-bit and 8-byte. Okay? What is particularly 8-byte unique code, and which is stored in the non-volatile memory EEPROM. Okay. So do you have any idea about EEPROM and non-volatile and volatile memory? Do you know what is volatile and non-volatile memory?
No.
Okay. Don't have any idea about volatile and non-volatile memory. Do you know what is EEPROM?
Full memory.
It's a memory, but it's an internal memory. Okay. But what's the significance of non-volatile memory? Just tell me. Could you please tell me about this non-volatile memory?
No, sir.
Okay. So, see, you are uploading the code and store the code to a memory, but this memory can be separated into two sections. One is volatile and the other is non-volatile. So whenever you are putting something in EEPROM or EEPROM, that memory will never be changed. Like you were disconnecting the Arduino, you have take over that particular 80 mega 3280 chipset. When this particular memory has been set over there, particular sketch has been set over there, that code will never be changed unless you reset it or unless you will upload another code over there. So whenever you are uploading something on the volatile memory, it means whenever you are shutting down the memory, you close the system, then the code will be finished, the sketch will be finished. Okay? So it means you are setting something permanently. Okay, unless you erase it, unless you erase it or have a flash on it, it will never be changed. Okay, so what it indicates that every sensor has 64-bit 8-byte unique identification code, which is fused, permanently stored, and internally during manufacturing. So every sensor has its own manufacturing code that has been internally connected with the family number, family code, and the particular what? Byte and bit integrations. Okay, that's an important question, that how it works. Suppose you are getting a sensor, obviously that sensor has some unique number, and that number indicates with different value, different address. Whenever you are working on it, Arduino will call that function, will call that integrated memory, and you can interact with the memory and the system over there. Right now you have interpreter, right now you have something that is very much easy with the help of the library and other stuffs. But when it comes to assembly language, at the time of 10 years ago, 15 years ago, 25 years ago, 30 years ago, it was really defined like this. I have a particular number, you have some hexagonal input over there, you have the memory, you have the byte zone, so you have to interact like this. In today, are you going to work like this, something good? No. You have all in your hand, all subs in your hand, you have updated system, updated version, interpreter, and so on. So you don't need any kind of bit or byte address, but in internal, still this memory will work like this with the integration of sensors. Okay. So where I was now. So there are a bit of 5 and 6 configuration bit, same like this. You have some partition over there, and that particular partition will have significant role to play with the particular parameters. That I have 23.5, so that's an integer number. I have to work with this middle range particular bit. Okay, that's a plus. Okay, fine. I will work on this plus sign. It's 0.5. Okay, I will work on the right side of the middle section. So that's the same thing over there. And this 5, 6, 7 is what they reserved. They stored. So to store, you need DRV register. Okay, you need a register or a memory. So there's a 64-bit unique ROM code I have asked over there. There will be some ROM code over there. That's not very important. I'm just discussing on it. Okay, there will be a family address, family code address, something like that X to F or something like that. You will see over there. You have already posted, and this temperature sensor it will be connected with this, and the EEP ROM will be connected over there. See, there's an important thing. Configuration high, low is set up over what? Non-volatile memory. Because every time, whenever you must check with the integration, when to check the status, then you need the particular memory. The code could be changed, the environment could be changed, everything can be changed, but you have to keep in memory that I have set my particular data, particular position, high, low, and configuration over there. The rest of the things and other of the things can be set to the volatile memory. That could be erased. I don't have any kind of concern on that. Okay, but I have a kind concern, I have a kind attention to see that what is not working apart from the EP ROM. Okay, so in terms of checking, you need some fixed foundation, and that foundation has been put up over there. Okay, so this is the important thing, and that's how it works actually. It's very simple. So you have a Arduino, and there's some internal register over there, ALU over there, okay, register, shifter, memories, and the scratch pad memory is something like that. That memory 8-byte will be occupied with the particular temperature sensor. Okay, and then this EEP ROM that has been connected inside of the Arduino. Okay, this memory. Yes, but it also has been set over there. Okay, so this memory has been set over there, and you want to you can work over there. Like you can see, I have uploaded a code, but if you upload that code to the EEP ROM, so how is this possible to upload a code EEP ROM, right? So you have to declare like that you are going to work on this EEPROM. Like whenever you are going to declare a function, declare a library, what usually you do at the time, you just take the library of DST11, you take the library of LCD display, something like this. So it's something like you have a EEPROM, you have to call that EEPROM that yes, I want to upload this code to the EEPROM sections. I mean this memory. So whenever you want to upload this, every time you upload the code or something like that, it won't erase or it won't get changed. Okay? So that's how it works. But right now we don't work like this. In this era, we usually don't work like this. Okay? So this will be important for the exam. Like we have established so far models and outputs in our current time that has been executed with the AI and machine learning. So according to these things, according to this era, this particular system, they are like niche and baby child or something like that. Okay. So the thing I have been talked and discussed over there, these are the stuffs actually, like how data has been stored, how this partial fraction of the temperature has been stored, how this integer part of the temperature has been stored. And it's something bit 0, bit 1, bit 2, bit 3, same things, okay? To the power 4, 6, 5, 4, 3, 2, 1, something like that. I mean, bit 4 means to the power 0, minus 1, minus 2, minus 2, minus 2. Okay? So what I have talked over there? Fractional part, and this is the fractional part. Okay? So, this is the 0 to 7. 8 bit and 7 to what 15, another 8 bit. So it acts like an array. So my data 1 is my data 0. Okay, so you start from 0, counting 0. So that's how it works actually. Codes are not so difficult, but I don't want to explain on this. So the rest of the things is something about BMU 280, because 180 and 280 is almost same, because there's some basic difference over there. And this gyrometer is for only 2 more questions. But this load sensor is very much important. I will discuss this load sensor and the execution of the load sensor and how we measure the weight of our body. We calculate the value of the particular purchase, any kind of vegetables, items, rice, whatever it is. How we put over there into the machines and how this machine calculate your value and show the output of the particular weight. Okay, so basically there's a transducer. It's not there is some pressure sensor. It's not the pressure sensor basically. There will be some transducer actually that take your input as a weight. Yes, this appearance will calculate as a signal, and that signal will be calculated and evaluated by the load sensor, and that load sensor will execute some data like signals or something, and that particular bit signal will be organized and will be calculated and will be examined by the Arduino, and then at the end of the day it will show the output.
Question আসলে আমরা যদি ড্র করতে বলি তাহলে কি উপরে একটা ড্র করতে হবে?
Yeah, you have to draw this. I will talk and discuss the next class in details. So till now I have covered up to block 4. The things, the questions, the topics that are not discussed over there will not come to the exam. What I have explained to the board over there, that things must come to the exam. So there's nothing need to worry about that. The syllabus is so much short, and it will get much shorter time of exam. Okay, so that's it for today, and I hope to see you in the next class. Thank you. Assalamu alaikum.